Introduction to Geology. What is geology? Geology is mainly concerned with studying Earth and its processes. You can look at that as the study of evolution of Earth. The term geo stand for Earth and logy stand for discourse in ancient Greek. It is a major branch of Earth science. I would say it is the foundation of Earth science. Others include geophysics, GIS, engineering geology, planetary sciences such as studying Mars or Moon, for example. Geologists are interested in studying minerals, rocks, chemical and physical processes that includes erosion, landslides, seismic activities, volcanoes, rivers, natural resources, oceanic activities, and so on and so forth. You can view geology as a science as well as an art because it requires you to be artistic, especially when you are looking at maps and identifying minerals, but you also have to think like a scientist because it involves a lot of geochemistry and physics and mathematics. What do geologists do? Monitoring and prediction of natural disasters such as earthquakes, tsunamis, river flooding predictions, for example. Risk assessment of localized geologic processes such as landslides. Urban and rural development or engineering geology. Geologists work with other professionals such as engineers to assess ground stability, for example, slope stability, groundwater seepage into engineered structures, and so many other factors as well, such as stability of bridges or large scale buildings. For example, you cannot build a long lasting train tunnel without studying the geology of the area. Another things that most geologists do is the management of water resources such as hydrology or hydrogeology. In terms of water resources, this include both potable freshwater, other freshwater resources, and oceanic water. Natural and economic resources such as mining geology, petroleum geology. Public and private sector like resources. In other words, you may work in a public sector, you may work in the private sector. As a geologist, you may find opportunities anywhere because it's a very broad scale of expertise. In terms of major branches of geology, there are historical geology, which is a highly academic area of expertise that deals with the origin of the Earth and its development through time. In the 20th century, geologists have started to look at other planetary bodies in the same way that we have developed to study the Earth, which is we call the planetary geology, or mostly related to space exploration. It's sometimes known as the astrogeology, and it relies on known geologic principles to study other planets other than the Earth itself. And finally, the most common type would be the applied geology, and there are many subcategories in applied geology such as mining geology, petroleum geology, engineering geology, hydrology, environmental geology, etc., etc. And I will post a lecture on branches of geology sometime later. So let's look at the history of geology. Ancient Greeks wrote about fossils, gems, earthquakes, and volcanoes around 300 BCE. That's about 2,300 years ago. Then the Scottish physician named James Hutton came along, and he pretty much introduced this idea of uniformitarianism. And he also introduced these fundamental principles of modern geology. As well as we have the English geologist William Smith, who introduced the first known modern geological maps, which is pretty much this one, with rock strata. So that is the first known detailed scientific analysis of land, pretty much, in terms of different types of rocks and strata. Then we have a Danish scientist, Nicholas Stetno. I don't know exactly how to pronounce his name. Sorry about that. He introduced the law of superposition, principle of original horizontality, and principle of lateral continuity. And obviously there are many other people who may have contributed to the development of geology that are less known. So even before these guys came up with the modern day geology, we had other people who actually studied geology, study the earth itself. And one of the concepts that were popular long before these guys came along, called the catastrophism. Just like it sounds, it means the earth features form in a single catastrophic events and remain unchanged thereafter. And all physical geological features such as mountain, rivers, general landscape, everything remain the same, unchanged. It was mostly popularized by the Western Christians, especially by the Archbishop James. The idea behind this is basically the majority of things that you see, such as mountains and rivers, were created in one single event. So it's not a huge long-term process like we know today, but they believe that the earth was formed in a single event, and all the other formations form in individual independent single events. And they believe the earth was created around 4000 BC, and nothing has changed ever since. So in modern geology, we no longer accept the theory of catastrophism. Instead, what we did actually, we found way to understand the earth by understanding the layers of rock and geological material that we deal with. To do that, one of the most fundamental way of analyzing this information is using the history of the earth. To understand the history of the earth, one of the methods that we use is what we call the relative dating. Relative dating methods are as old as geology itself. It has been used by Greeks and Romans, Indians, Chinese, everybody else have used them. So instead of using the theory of catastrophism, we use theories that brought forward by people like James Hutton and others to understand the evolution of Earth. So to do this relative dating, what we do actually, we use these fundamental principles and laws. The principle of uniformitarianism, law of superposition, principle of faunal succession, principle of intrusive relationships, principle of cross-cutting relationships, principle of original horizontality, law of included fragments, and a few others. And I will talk about each of these fundamental principles in depth on a later video, but for now what you just need to understand is that we use these kind of dating principles to analyze the modern day Earth. The other method is absolute dating. It is also known as radiometric dating and geochronology. It is a part of the geochemistry branch. and it developed in early 20th century with the advancement of technology and science. For example, you can just see this is a dating of zircon, which is a very common mineral we use for dating rocks. Pretty much we can use a laser to analyze the edge of the zircon, for example, or we can take a sample from the center of the zircon, and we can pretty much date accurately how old the zircon itself and the rock itself which contain the zircon, for example. And I will talk about zircon again on a later video. For now, what you need to understand is there's two types of dating. One called the relative dating, the other one is the absolute dating. The geologic time scale is a very important thing for all geologists, engineers and geophysicists, everybody else as well. The reason being, it is like the periodic table of elements but for geologists. So geologic time scale is composed on both relative, like it is based on both relative and absolute dating. This is what the current time scale look like. The International Commission on Stratigraphy often revise the boundaries between each of these sections, and these time sections are often either debated or a change or a rename, and sometimes even new time sections are being introduced as science progress. However, for most undergraduate students in geoscience and engineering, we use a relatively simple time scale. Like we don't need this much detail, especially for undergraduate studies, unless you are doing obviously research. So instead what we use is a simple version of geologic time scale that most students will find sufficient. It is divided into larger sections called eons. Like here you can see Phanerozoic, Proterozoic, Archean, and then these sections were further divided into era and periods, like for example Cenozoic, Mesozoic, Paleozoic, and further divided into Quaternary, so on. The Quaternary period and Holocene epoch is important because that's the time section that we live in. So here's another example of the same time scale, it's just drawn differently. So spheres of the earth, there are couple of subdivisions. To understand the earth, scientists try to categorize the earth itself. To do this, we have developed couple of spheres. Like we define what a sphere is. It's obviously arbitrary. So there would be hydrosphere, biosphere, lithosphere, atmosphere, and those are the four major spheres. The easiest way you could remember this is that basically hydrosphere is water, biosphere is living things, lithosphere is land, and atmosphere is air. As the name suggests, the hydrosphere includes all the gases, liquid and solid water of the planet Earth. It extends below the Earth's surface into the lithosphere and high above into the atmosphere. Global ocean is the most predominant feature of the hydrosphere, which basically includes more than 70% of the Earth's surface. Like the global ocean covers about more than 70% of the Earth's surface, and global oceans also includes more than 97% of the Earth's water. Sometimes it is not always obvious on what components included in the hydrosphere. For example, snow. Here's a snow in my backyard, for example, during winter. It's still part of the hydrosphere. It just happened to be snow. It's still water, right? So this is still part of the hydrosphere. Freshwater also includes streams, rivers, lakes, glaciers, also snow, obviously. They are also part of the hydrosphere. Biosphere include all living things, or you can call it organisms in the planet. Humans, plants, animals, microorganisms are all part of this sphere. Biosphere has been further divided into biomes or ecological areas such as desert, forests, grasslands, so on and so forth. And the next one is lithosphere. Litho mean in Greek rocky. So obviously lithosphere mean studying rocks. So that it would include all the hard rocks and the minerals and stratigraphy, everything is part of the lithosphere. It includes the crust, the uppermost mantle, which constitute the hard and rigid outer layer of the earth. Lithosphere itself is broken into tectonic plates, and again I will do a separate video lecture on tectonics. Include physical landforms such as mountains, valleys, and everything in between. The liquid, semi-liquid and solids on the earth itself is still part of the lithosphere, such as which includes the crust, mantle and outer core. And the layers are, the reason why we have this separation of crust, mantle and outer core, they are chemically and physically different from each other, and you can differentiate them between these three. The most geologists deals with lithosphere more than any other sphere, but all spheres interact with each other, and you need to understand each and individual component to excel in geoscience. So for example, this is lithosphere that includes mantle, outer core, inner core, but most of the time as a geologist you're probably going to deal with the top part, the mantle, the crust part, right? But however, you need to understand the earth processes, not just from lithospheric standpoint, but also from other biosphere and atmosphere and so on, to understand the interaction between each different spheres. Finally, the last sphere is the atmosphere. As its state, atmo mean air, so it includes all the air or gases in on the planet. It plays a major role in supporting living organisms on Earth. Without the atmosphere, it would not be possible to live on Earth. In fact, Earth is one of the unique planets with an atmosphere. Most planets do not have an atmosphere. Atmospheric components includes nitrogen, which is about 78%, oxygen about 21%, and other gases about 1%, which include carbon dioxide, argon, and some trace gases such as krypton, neon, etc., etc. You may come across a term called geosphere. Some geologists and instructors would use that term. The geosphere is a collective name for lithosphere, the hydrosphere, and cryosphere. Cryosphere and the atmosphere. For our particular series, we will not worry about what geosphere, what's the difference between geosphere and everything else, but just I'm putting it out there just for your information. You may come across the term geosphere. So thank you so much, and that's everything for today. You can practice your knowledge, maybe not at the end of this video, but after you've gone through all the series at this location. I'll leave the link in the description. You can find more exams here, and if you have any questions, feel free to contact, and don't forget to subscribe. Have a nice day.